Surprise! You can't get rid of me. Good morning. Today in math, we're going to look at quadrilaterals some more. Last week, we created this anchor chart to show the different organization of quadrilaterals. They're all in the parallelogram club except for poor trapezoid. And then we've got the rectangle club because they have all right angles. And we have the rhombus club because they have all the same equal sides. And then the square is everything. A square is obviously a square. It's a rhombus because it has 4 equal sides. It's a rectangle because it has 4 right angles. And it's a parallelogram because it has 2 sets of parallel lines. And it's quadrilateral because it has 4 lines. A square is the coolest kid in class. So today we're going to look at this exact same organization but in a different way. And then you're going to copy this anchor chart. So up at the top I have written, mathematicians organize shapes to better understand their qualities and relationships. So how are the shapes related, connected? How are these shapes similar and how are these shapes different? Things like that. That's what we're talking about. So we're going to start with polygons, just to kind of review. A polygon has 3 things that it must have. Anybody? Closed shape, no open spots. Straight lines, no curves. And lastly, it's flat, 2D. It's not a 3-dimensional shape. So we're going to start with polygons. We've talked about several different types of polygons. One of the types of polygons that we talked about has 3 sides, and that is a triangle. So let's put triangles here. And we've been classifying triangles in different ways with the angles. We could have acute, where they're all less than 90 degrees. We could have a right triangle, where we have one right 90-degree angle. Or we could have an obtuse triangle that has one angle that's greater than 90 degrees. So I'm just going to write triangles here, and I'll kind of draw. Ooh, an upside-down triangle will fit perfectly. Triangles. A few other shapes that we've talked about that don't have 3 sides, but they don't have 4 sides like our quadrilaterals are like the hexagon that has 6, the pentagon that has 5, heptagon, things like that. So we will put just figures with more than 4 sides here because they're still polygons. Figures with more than 4 sides. And let's see, if I was really good, I'd be able to draw a pentagon. Uh-oh, check this out. Upside down house. 1, 2, 3, 4, 5. Pentagon. Okay, so that would be, again, pentagon, hexagon, heptagon, decagon, nonagon, octagon. All of those would go here because they're still polygons. But then our main polygons that we're going to talk about have 4 sides. We call those quadrilaterals. Quadrilaterals. Oh, I couldn't fit it all. Quadrilaterals. So now we're going to talk about each of the quadrilaterals that we've been talking about. So, first of all, the little guy who doesn't really fit in with the other group, we're going to mention trapezoid first, because he's kind of off here by himself. Trapezoid. Okay, now I'm going to fill up the rest of this paper in order of qualities so that we can see what should be at the bottom. What's that coolest kid in class that has all of these characteristics? The square is going to be at the bottom. So, first, under our quadrilaterals, we're going to have parallelogram. And remember, a parallelogram, you mostly see it like a rectangle, but slanted or tilted. So, parallelogram, 1 R, 2 L's, parallelogram. And remember, parallelogram just means it has two sides, two sets of parallel lines. So the top and bottom are parallel, they'll never run into each other, and then the two sides are parallel, they'll never run into each other. So we have several shapes that are parallelograms. Oh, lights just went off. Sorry. One of the shapes that is a parallelogram is the rectangle. Looks just like the parallelogram, but straight up and down to have 90-degree angles. I'm going to do a long down rectangle. Rectangle. And I'm going to draw those little 90-degree angles. Then the other significant parallelogram has all four sides the same, and that is a rhombus. So it looks like a diamond. Try to get all four of those sides the same. You know, I just realized that music is playing in the background. Sorry, I hope that's not bothering you. Rhombus, don't forget that silent H. Now I'm going to put those little dashes, slash marks on each line to show that each side is the same length. So then we have one quadrilateral left that has two sets of parallel sides, that has all four sides the same length, and it has four right angles, and that is the square. So both of those are square, or no, I should say square is both of these. So again, let me review why I drew the chart like this instead of the one that we drew last week. This really shows, this is called the hierarchy. Maybe I should write that down. I know I've mentioned that. I think we wrote that in our learning targets. All right. Hierarchy. And a hierarchy just means categorizing things from top to bottom. So, from the top, we've got closed figures that are not 3D and that are not rounded. Under that, we have quadrilaterals, which have four sides. Then we have parallelograms, which have two sets of parallel lines. Then we've got rectangles that have four right angles. We've got rhombi, plural for rhombuses, that have four sides the same length. And then we have square. So, if I were to classify the hierarchy of a square is a rhombus, a square is a rectangle, a square is a parallelogram, a square is a quadrilateral, and a square is a polygon. Ponder on that. I will see you Wednesday.